Hello and welcome to section 12.5. We're going to be working with volume of cones today and volumes of pyramids today. Here are the answers for 12.4. Again, you may have done these problems differently as the book has their way of doing it and I have my way of teaching it. So keep that in mind when you're taking a look at your solutions. And you can see in 26 here, there's trigonometry. Very typical for these problems. Same with today, you might see some trigonometry in there, you might see some skills that you've learned in the past that you have to apply. All right, what we're working with, like I said, is volume of pyramids and cones. The formulas are identical today, base times height. However, the corresponding pyramid to the cube is 1/3 the volume. And same with the cylinder and the cone. There's videos on YouTube that you can watch. I'm not going to put them in here. You can type in how to find volume of a pyramid demonstration, and basically some guy takes some cups with water of the shapes and they dump it in 3 times to show it's 1/3 the value. So what we're looking at here is 1/3 base times height. That's all you need to know is you find the base, find the height, not the slant height, okay? Keep in mind we're talking about the height, not the slant height, and then divide that by 3. So it's actually a pretty quick lesson here. So here we have this looks like a triangular, right triangular pyramid. So I'm going to find the base, so I need to do 4 times 6 divided by 2. That's the base, 1/2 base times height. Just a triangle that we're going to start off with there. And then that times the height, which is 9, and then all that divided by 3, and that would be your answer. Here I have an oblique sort of cone. So I'm going to do pi r squared, so 2.2 squared times pi r squared. Okay, that's my base. My height is 4.5, and then I divide that by 3, and that will give me my volume. There you go. And as you can see, the way the book did it, slightly different than me. That's okay. All right, originally the pyramid had a height of 144 meters and a volume of 2 million something, whatever. Find the side length of the square base. Okay, this is a problem where we're going to go backwards. So what we're going to do is we're going to set up our formula. So 2, 2, 2, 6, 4, 5, 0. That's the volume, and that equals 1/3 base times the height, and the height is 144. So what we're going to do is first we're going to find the base area, and then what we'll do is then we'll find the side length by square rooting it because it is a square. So if I know the base area, then I can find the side length of the pyramid. So I'm going to start by doing 144 divided by 3. See what that is? 48. So this is really 48b if I do that operation there. So I'm just going to divide by 48 on both sides, and that will give me the base area. So 2,226,450 divided by 48 gives me, I'm just going to double check that I typed that in my calculator, right? Okay, so that gives me that number there, and that's the base. So the base is really side length squared, so we'll call that x. And that x is kind of hard to see. Let me use red here. X and x. So I'm going to square root both sides. And we're going to find out that x is equal to, if I square root both sides, about 215.37. And that would be in meters. So there you go. Let's see what the book did here. Book did very similar stuff here, it looks like. They multiplied by 3 and then divided by 144. I just did the 1/3 and 144, so I kind of simplified up there, so I did a little bit quicker. Okay, using trigonometry, find the volume of cone. Ooh, look at that, we can do trigonometry, fun. And you guys are going to see this in your homework, of course, because I believe trigonometry is very important for geometry students, so I like to review this. So what we got going on here is we have pi r squared times the height is 16. I need to find the radius. Oh, divide by 3. Don't forget about the divide by 3 part. I need to find r, and I'm going to use trigonometry to do that. So I have opposite, and I'm looking for adjacent, that'd be tangent. So tan 65 equals 16 over r. I'm going to multiply both sides by r because r is in the denominator and I cannot have that. And then I'm going to divide by the tangent of 65. So hopefully this has you've gotten pretty quick at trigonometry since we've been seeing it consistently come up in the homework. So we're going to take 16 divided by tangent of 65. That gives me 7.46. Okay, so 7.46. Alright, so we have pi times 7.46 squared times 16, all divided by 3. Plug that in your calculator, you're going to have your answer. That looks just like mine. Now you're going to notice here, you're going to notice this 1/3. I do versus me, I do the divide by 3. It's the same thing. I personally like doing the all over 3. But you can do it however you'd like. Alright, find the volume of a solid. So here it's just, this is a composite solid. It is a cube and it is a pyramid. So, I mean, there's really not much to this. I have 6 times 6 times 6, or 6 to the 3rd power. That's going to be my cube. Plus I have 6 by 6. 6 times 6 is my base, times my height, which is 6, divided by 3, and then that would be your answer there. So that's actually a quick problem. As you guys can kind of tell with volume is generally going to be quicker than surface area questions. I think I got just one more question for you guys. Yeah, just one more. You're using the funnel shown, and we're figuring out how long, what's the flow rate, okay, in millimeters per second, okay, and it says that 1 milliliter is 1 cubic centimeter. So we're going to find the volume, and it takes 2.8 seconds. We're going to divide those. We're going to figure out how fast the sand is flowing out of the cylinder, basically. That's what they're looking for. So the volume of the cylinder is equal to pi times, sorry, not cylinder, cone, pi times radius squared. The radius is 4 times the height divided by 3. So if I do that, I get a volume of, let's see, 16 times 6 times pi, and then divide that by 3. I get a volume of 100.53 cubic centimeters, which is, cubic, that should be a 3 there we go, which is the same as 100.53 milliliters based off of this simple conversion that they give us here. And then we're just going to take that, we're going to divide it by 2.8 because that's how long it takes. And we get an answer of 35.9 milliliters per second. That's how much sand is flowing out of there, out of that cylinder. Okay, so they rounded up to 101, so their answer is actually less accurate than mine. All right, there you go. These problems here, this is supposed to say 2. These problems here that I marked as challenge problems, they're not really that hard. I just shortened up the assignment for you guys, so it's a little bit less work. But yeah, give them a try if you are a little bored and want to do a few extra problems. Thanks guys for tuning in.